So in C++ language, we can define enumeration or enumeration type like this. So enum is a keyword that is used for that. Color, that is the enumeration type. It is a user defined type. Then these are the possible values: red, blue, green, yellow, black, whatever the values we have mentioned there. Then this is the type. This is a data type. Okay, we have defined it. It is a user defined data type, and for that we have used this keyword enum. Now see, now we are defining a variable of this user defined data type. So we are defining two variables. One is my color and another is your color. So what values we can allocate or assign to these variables? So any value from this that we can assign it. So for example, see, for my color variable we are assigning blue. Your color variable we are assigning red. Like now see, why it is the ordinal type? Because these values are associated with the positive integers, set of positive integers. How? So see, it is associated with the 0. It is associated with the 1, 2, 3, 4. So if you add more, then again it will get incremented like that. So 0, 1, 2, 3, 4, and if you add again, so 5, 6, 7, 8, like this. So this is how we define enumeration type in C++ language. So we'll see program for that. So see, this is a C++ program. So here uh, enum keyword is used. Colors is a type, user defined type. Any name we can give. This is a we are defining a type here. What are the possible values? This, and it is linked with the set of positive integers that I have told already. So 0, 1, 2, 3, 4. Now see, this is a color type. We have defined that user defined data type. My color is a variable. Your color is a variable. What value we have assigned to my color? Blue, and your color is red. Now we are printing on the screen. So see, if you run this program, so what output you will get? So now we will run this. So here you can see. So my color, what value we have assigned? Blue. So blue is the second one. So 0, 1, 2, right? 0, 1. So that's why 1. Then your color is red. So red is first one. So starting from 0, 0, 1, 2. So that's why it is 0. So your color is 0. So likewise, this enumeration type is implemented in C++ language. In the same way, it is implemented in C language. So this enumeration type first introduced by C and Pascal language, and afterwards C++. So in C++ language, it is taken from the C language only. In C++, enumeration constants. So see, whenever we are saying enumeration constant, so enumeration constant means this value. These are the enumeration constant. So red, blue, green, yellow, black. These are the enumeration constant. So in C++, enumeration constants can appear in only one enumeration type in the same referencing environment. Now see, what do you mean by that? Here in this example, so see, one type I have defined, that is the color. Now suppose if I take new data type, suppose, and another name I am giving. So for example, new colors, and I'm allocating some values. So suppose these values I'm allocating. So what I have done, I have defined new type. So first was colors, and now I have defined another data type, that is new colors. Now whatever the values I have added here, same values I am putting there. So red is there, blue again I am taken from here, green also I have taken. But this is not allowed in C++ language. So see, red is present here also, and red is present in here also. So red value it is present for the new colors also. So this is not allowed in C++ language. So if we run this program, so we'll get error. So see, if we compile this, so we'll get error. So what kind of error we are getting? So redeclaration of red, redeclaration of blue, redeclaration of green, as we are redeclaring it. So enumeration constants cannot be used multiple times in C++ language. So this is the meaning of this sentence. Enumeration constant cannot be reappear. It cannot be reused. Then what are the advantages of enumeration data type? So there are two advantages. One is readability and another is reliability. Now see, what do you mean by readability? So they have the values. So here they have value 0, 1, 2, 3, 4, and instead of using values, here we are using names, and that's why it becomes more readable. So instead of some value, now see, by default it has some value 0, 1, 2, 3, 4, 5. We can allocate our values also. For example, see, if I want to allocate this value 10, 9, suppose I want to allocate some other values 4, 5, and suppose 3, something like that. So if we want to allocate our own values, we can allocate it. Now see, we will compile it and we will run. So my color blue, that is 9, and your color red, that is a 10. So we can define, we can allocate our own values to this enumeration constant. So instead of these codes, we are using these names, words, and that's why it is more readable. Then why it is reliable? Why it is reliable? Because see, in this example, whatever the values are allocated, so 10, 9, so only these values can be used. There are no other values can be allocated to this enumeration constant. So what, while defining this, whatever the values we have mentioned, only those values can be used. Outside these or other than these, no values can be assigned, and that's why it is reliable. So these are the two advantages of enumeration.